This is Ray's Magnetic Battery Part 5. Part 4, we were demonstrating that magnets have the ability to stir up some currents, or they're attracting different charges to the surfaces of the different fields on the magnet. I've two magnets here. I've coated them with, or wrapped them with, aluminum foil. This is north on the top, so it means south on the bottom. This one's south on the top, which means the bottom that is contact with the earth is north. Okay, I've had this setting for quite a while here, trying to get the charges down to where they're not moving around. The purpose of this is to control the voltages a little bit better than I did in part 4. It was kind of a lottery type thing. You didn't know what you was going to get. I wrapped them with aluminum foil so I could put my probes and hold them in there better. Okay, we have 0.006 volts. Okay. I'm going to move this one. We have 0.3 volts. That was stirring the charges within the ground. Here's the theory. When free charges are within the earth, are in contact with a moving magnetic field, they're either going to be attracted or repelled to those surfaces. The earth is made up of many loose plus and minus charges. Okay, that was a negative reading. We're going to move the other magnet, and we have a plus. It went up to a point plus 3. And it's dropping also. So it seems like one face of the magnet is attracting one type of charge while the other face is attracting the opposite. So we have a control here. We can either make it a minus reading, a negative 0.4 volt, or we can make it positive. Okay. So according to the theory, the charges within the earth are what's being affected. There may be also a current within the earth that is also an added feature, and it comes into play when the magnets are moved. That'll be another video, but for right now the theory is, for what we're watching, is that there's different charges in the earth, and the different battery or the magnet fields are attracting or repulsing those charges. So we had a negative 0.4 volt, and a positive plus 3 there. So the difference between that is about a 0.7 volts. That's pretty good for just a magnetic field. And that is my conclusion, that it is the magnetic field affecting this. Otherwise, if it was some type of other type of capacitor effect, one thing that doesn't lead me towards that theory that there's capacitor effects there is that they use ground for an effective solid line. There is no, when they ground things, it's, it's wherever they put it, it's going to read the same. So a capacitor effect, I can't see it doing that. It was discharged so quickly that when you were done, because the earth is normally associated with a ground, a neutral potential, so everything would drain off really quick. But these do not drain off that quickly. If it was being shorted out by this ground, then if there was little capacitors in there somehow, they would leak out really quick. That makes it nice and complicated. So anyhow, here we go. We can make it a plus 0.4 volts. And there's a negative 0.4 volts. So that's about 0.8 volts in between, using magnetic fields to produce that voltage. I don't know what the current would be. I need a new voltmeter, and that's maybe far off in the future, depending on bread or butter, or put a new voltmeter on the table. So anyhow, I hope you like this. It kind of concludes to me that there is a magnetic effect going on here, negative, or we can produce a positive effect on control. So it's more like an on-off switch, and in part 4 we didn't have that. So this is a better control. You can see what's going on. This can be duplicated pretty easily. I hope you had a good day, and happy inventing.